Yes, sir.
Okay. So today, I think we are coming to the computer network syllabus part. I think last 3 days already we covered the several tools related to computer networks and the practical experience that is provided by the earlier resource person. So it is, I think, a good experience for all participants of this FDP. And today we have to go towards the syllabus part. So I have assigned the portions related to syllabus, especially in 2024 syllabus, we have added several hands-on experiences that is part of the layered different layers of the computer networks. And earlier schemes, we are following the syllabus from physical layer to the application layer. That is the direction of teaching, our teaching. But the current syllabus preferred uh, application layer to physical layer concept. That is upper layer to lower layer concept. And the textbooks provided for our syllabus is also a new textbook. Earlier, there are some textbook related to this type of concept, like Koros and Koros, but currently we are assigned a new textbook. So in that syllabus, I think you already have seen the syllabus. Have you seen the monitor? Okay. Okay. So today my session covering the topics related to network layer. That is Linux kernel implementation of routing table and caches, routing cache implementation overview, adding new entry in the routing table using IP commands. So it is a hands-on part. So I try to cover the overall idea on this concept because it is more theoretical oriented, and we have to demonstrate some commands there, but the whole mechanism I am not implementing because for that we have to use different tools such as Wireshark or TCP dump, etc. So I try to give some idea as a demonstration and more explanation on the theoretical aspect of that particular part. I think you understand or you get the idea. So that is the flow of this session. So I think it's a good experience for you, and anyone can ask any related questions. And I think I'm also a teacher for the computer networks. So I have some experience of 20 years, but I think teaching is a part of studying. So I try to give some information on this Linux kernel implementation of routing table and cache and routing cache implementation overview. So any queries you can ask me through the messages, or you can in between I will give the intervals. At that time also you can ask the questions. Can we start?
Yes, sir.
Okay. So these are the area we are covering in this part, and basically some idea on routing. That's the fundamental ideas, and what type of mechanism we are following in the Linux operating system, and some concepts such as multipathing, etc. And then we are moving to the cache concept. That is the main concept given in the syllabus. Then managing routing cache, and there's an information base that how we are implementing FIB implementation, and RT netlink interface, then related commands or related functions to the Linux implementation. Okay, so that is what I am the main contents of this session. And initially, I think almost all teachers already took the sessions on computer network, so you have more idea on this concept. But anyway, I have to start with the session, so I am starting with some introductory part. So basically, the routing fundamentals. So we know the concept. We are using the part of session is a part of network layer concept. So the one of the main main core idea on the network layer is routing. So we are and here we have Linux routing table implementation. So we are following the Linux operating system, and what all the basic concept related to Linux operating system in or how it following the network layer. Okay. Basically the unit of information carrier in the internet is a packet that contains an internet protocol header that carries. So routing means the term we have an idea is IP, that is internet protocol. So the basic protocol which helps for the routing part or routing process is internet protocol. There are several versions, IP version 4, IP version 6, etc. So currently in this session, we are following the IP version 4 concept. And there are IP means itself it directed to the concept of internet. So what is internet? Internet means it's a network of networks, or it consists of large number of networks. So we have a idea on a simple network, or we have labs at our college. It's a local area network, and several local area network in our institution, and the whole networks are connected, and these labs are or these local area networks are connected to the external network through a router. Then it is a part of internet. Okay. That is what the basic concept we are following with the network. So internet means it's a network of networks, and there's a backbone. I think we have the idea on autonomous system. So there's a core network is there, and several autonomous systems are there. All autonomous systems are connected to the core network, and inside an autonomous system we have several routing protocols we are following, and in between communication between the autonomous system, again we have the exterior gateway protocols. So that is what the routing process continues. Okay. And the backbone is there. In that backbone, all the autonomous systems are connected, and they are connected through in order to send messages, or we have to transfer the messages. There are several routing protocols we are following. Okay. And it's a unique internet protocol address. So in order to transfer data, we need the address. So addressing is also part of network layer. IP protocol, we are following the IP protocol means in that IP protocol, in order to communicate, we have to communicate between two network means there need a concept. There is a concept of addressing. That addressing is provided by internet protocol address or IP address. Okay. And internet has mainly two components. They are router and network. So networks are there, routers are there. This is the IP routing basic overview. That is, we got messages from different applications, and those applications are segmented in TCP, and those segments are sent through the network using this IEP concept, Internet Protocol concept, and we have the end systems, and all the end systems are physically connected. Those end systems are transferring the message through data link layer and physical layer. Okay, so this is the basic or an overview of the IP routing. And this is the concept of networks and routers. So the large number, we have a shady part, that is router, and the open part is the network. So it is provided as N. So several networks are there. Internet means a large number of networks are in the internet, and they are connected through routers. Routers are the endpoints of the network. We are connected, every network connected to a particular router, and the router address of the router providing the address of the network. Okay, we have incoming link and an outgoing link, and several concepts related to this mechanism is there. So we will follow in the next slides. And one of the main part of the routing concept, okay, that is routing table. So we are in this part, in this session, we are handling with the routing table. So the main part of the routing or the routing process is routing table. Okay, there are we know the idea about the routing table. There are some contents are there. We already taught several algorithms related to routing. Basic algorithm like distance vector algorithm and linked state algorithm, and there we already taught the concept of routing table. I think you are all aware of that. I am not going in detail. So basically the core part of the routing process, core part of the network layer is routing table. It is a data structure related to the routing process. So the functionality of the network layer is routing, and the routing is supported by a data structure known as routing table. Okay, and we have also we have static routing table and a dynamic routing table. Static in some constant network we can follow with the static network, but the internet is it's not a constant network, it's a dynamic network. Always it is growing or shrinking. Some of the persons are leaving from the network, some of the persons are adding in the network at every moment of the life. So we cannot depend on a static network in the internet concept. So earlier in a local network, or we have a fixed number of systems, and we have such a lab, etc. We can provide the static concept, because there is not much change in the network number of nodes, and there we can create a static information, static table, static routing table, and that is given by the administrator, that is developed by the administrator. And there are several commands. I think already you have an idea on if config and route, etc. So that is what the existing system, and it is not growing dynamically. So we can follow the static approach on routing table creation. Now the second concept is dynamic concept, and dynamic means always there are systems are adding. Currently we have mobile networks are there. So every day someone taking new number or adding to the network, and someone sometimes leave the particular network and moving to some other case, some other location, etc. And we are changing the number also, means that the networks also changing. So we cannot keep, it is not insisting to keep all the addresses in the network. We can change or dynamically itself, someone removing, someone adding. That option is better for the internet network or IP concept. Okay, so there coming the concept of dynamic routing, and there are various protocols such as RIP, OSPF, BGP, etc. That is I already told. There are autonomous systems, and inside the autonomous system we are following the RIP, OSPF cases, and the communication between the core network, we have the border gateway protocol or BGP. RIP means routing information protocol. which is working on the basis of distance vector logic, and OSPF is another routing protocol which is on the base of link state concept. Okay, and this is the basic information on RIP and OSPF. RIP is router broadcast information about the neighboring network to all the other cases. So distance neighboring network give the information what is the distance between the two. So we are keeping the distance. The extension of distance vector algorithm is following in RIP. So there is a hop count or some other metric we are following, etc. And OSPF or RIP has some shortcomings that we already know. We have some shortcomings with the distance vector. So we are following the RIP concept, and there we are storing or passing all the link status of the route itself. So it is very effective for recovery of routes is concerned. Some in RIP, if we lost the route, it is difficult to recover the case. We have to restart the cases. That is the only mechanism. But in link state, we already know what is the status of the route, and according to that, we can decide on the open shortest path first routing protocol. Okay, and the basic principles related to routing in Linux. The information contained in the routing table drives all the routing decisions made by IP, and based on the routing table information, what all the informations we are keeping inside the routing table, and the basic performance of the IP following the steps. Search for a matching host address. So always there are options. Okay, we have three options. Okay, here search for a matching host address. That is the first option. So exact matching. We got a packet and we have the destination address, and we are checking whether that destination address is matching with the current host address. Okay, that is the case. That's the first part. Okay, so it is matching with the host address means we know the address, or that particular address is in the routing table, and it is exactly matching the destination means the process is completed, the data will be passed to that particular host. Okay, that is the case. Second one, search for a matching network address. So we by checking the routing table, the exact match is not getting, but the network address is getting. The network address is always the IP address have two parts, network and host part. So in the first case, we have the network and host part are matching with the destination address. But in second case, host part is not matching, but network part is matching with the destination address. So we can identify that that particular case is inside this network. So according to that match, we are accepting that particular node. That's the case. And the third option is search for a default entry. The default entry is normally specified in the routing table as a network entry. Always every network providing a default entry, and that default entry is assigned for forwarding the packet. That means the particular packet reached at a network which is not meant for that network. It is not matching the host address. It's not matching the network address. So we are passing it to, forwarding it into default entry, and that default entry will forward the packet. The default entry is normally specified in the routing table as a network entry with a network ID. So just passing the packet to that particular network entry. And a matching host address is always used before a matching network address. Okay. The routing done by IP when it searches the routing table and decide which interface to send a packet out is a routing mechanism. But this differs from a routing policy, which is set of rules that decides which routes go into routing table. That is coming in the next part. Okay. So what is the routing mechanism? We are following some mechanism. That is the steps we are following here. Every routing table following these three ideas. search for a matching host address, search for a matching network address, search for a default entry. And the default entry is according to the policy of the router. Okay. IP performs the routing mechanism while a routing daemon normally provides the routing policy. So IP doing the routing and policy done by the routing daemon or the router. Okay. Routing works on very simple rules. First, try to find out the matching entry that is already I told for complete destination IP address of the packet. And there is no match found, then all the network entries are matched against the destination IP address. If there is no match found, then all the network entries, we are not considering the host part. And if there is no matching network found for the destination, we take the default route in case any exists. Default route is always, sometimes there is a policy, sometimes such policies are not using. So according to that, we are deciding. So routing entries have the following basic entities. Network is there, gateway is there, interface is there. So gateway means it is the forwarding part. Okay. Our default part is gateway, and there is an entry gateway and outgoing gateways. So according to that, it will be decided. And interface part means it is passing towards the local area node or local area network case. Okay. And this is the basic diagram. I'm not giving more information on this case. I think any query part you can ask me. This is the basic network concept. So there's a gateway, internet towards the gateway. So it is a part, that gateway. Sometimes it providing the local network, or sometimes it will providing to other network concept. Okay. And this is the two other concept, forwarding as routing. Okay, routing means the collecting, exchanging topology, and we are following some protocols. According to the protocol, routing protocol, we are finding the path to the destination. That is the route gate concept. And forwarding means given a packet, determining the next hop, because there is no endpoint is there. So we are finding how to pass, how to route this particular packet. For that, we have to go for the next hop and finding the next hop and forwarding it to the destination case. And here we are not getting the exact route. We are just trying to forward the packet to the next hop. And this is also a basic concept. IP addresses, we know two types of mechanism, class-based ones and classless one. I'm not going in detail. And this is an example network. Okay. And the routing table. So we have the destination, network mask, router interface. Okay. I think we have idea on this concept. Okay. Destination means the address in the packet. Okay. Destination address in the packet. Network mask means what type of network we are using, or what is the network ID, or how we can differ the network ID. For that concept, we use the network mask. So there's a 24-bit mask is there, and sometimes the broadcast concept is there. So according to that, the network mask will be provided, and sometimes there is a default router concept will be there, and follow that particular router path. That is also a policy matter. We are deciding some messages for this destination should be forwarded to this particular router. That is the concept. And the interface, in what interface we have to follow. Ethernet interface, ETH0, ETH1, ETH PPP0, etc. According to that, the interfaces will be provided. This is the concept of routing table. This is the information given in the routing table. Okay. And in the Linux routing concept, so IP routing, we are currently we have the information on the Linux routing mechanism. That is the Linux Internet Protocol routing mechanism, and we have following some concept, especially in Linux routing mechanism. One of them is longest prefix matching. So more specific entries are preferred. So we are providing the mask. Okay, we have the network mask, and how extend we are giving the matching, or how extend we are providing the network ID. According to that, we are fixing the forwarding, fixing the default mechanism. That is, we have a packet, and the packet contains a source address and a destination address, and that particular destination address, how much it mapping, or how much extent it mapping with the given gateway, or given network mask. According to that, we are deciding the default part, default gateway. Okay, so network mask providing the network ID. So how much our destination address matching the network ID. Okay, that is the case. Longest prefix matching, that is the case. I will give the example. And second important property is routing cache. So we have already have the idea on cache mechanism. So cache is a faster memory in between the register and main memory. So here also we are providing a cache. So most recently used routing entries are provided in the cache. So in Linux routing, one of the important point is cache implementation. Okay, a routing cache implementation, that is important in Linux routing. Okay, and to speed up forwarding. Okay, cache is always using for speed up. Here we have to speed up the forwarding part. There comes the case of routing cache. And third one is rule based routing. Excuse me. Okay, rule based routing, a unified way to organize different routing tables, local, main, default, etc., each with a priority. So it's a policy based routing we are following in Linux routing tables or Linux routing mechanism. So we can create the rules. Okay, routing is based on specific rules. So it's a unified way to organize different routing. There are large number of routing tables are there in Linux, and we have to manage all those routing tables. There we have maintaining some policy mechanism or some priority, and local routers, main, general table, default, etc. So in initial, the first stage, that is exactly matching. So it's a local router, and not exactly matching. It matching the network ID. So there comes the general table, and not satisfying first two conditions. So we have to go for the default. So there's a default case. So we are by using some rules, we are maintaining these divisions in routing table. So according to that, we can easily direct, or faster way we can direct, or we can assign some priority also. In there are several default routing tables may be there. So in that case, we can prioritize them, and according to or that priority, once one destination address comes, it will be assigned to either local, or in which local, which prioritized the local, or main, which prioritized the general table, or default, which prioritized the default. According to that rule, we can apply the routing concept. Okay. And what is the longest prefix match? That is the first concept already explained here. And longest prefix match is the routing technique used to select the most specific route for a destination address. Okay. So we have a destination. Example, we have a destination 192.168.1.25. Okay. That is the destination ID. And we have a routing table is there. It contains a route and prefix length. And the route have prefix length 16. That means it is the mask. It's a class B address. If we are using the concept of class full addressing, it is a class B address. and another address that is a 24 prefix length. That means mask is 24. It is a, in class based concept, it is a class C address. Okay, we have to route in the network table. So the destination is already given, and how we can find the match or which route we have to choose. That's the question. There comes the longest prefix matching. So the selected route will be 192.168.1.0/24 because LPM search order always like this. Initially, if /32 means it is exactly matching the host, and /24 means the network is matching. In most specifically, it is matching, and 16 means medium specific. 8 means less specific, and 0 means it is not at all specific. So in that particular order we are finding the route, we are identifying the route for the destination. If it is a 32/32 concept means it is directly matching the host. If it is a direct /24, so or in between 24 to 32, that is the better specific network ID. And if it is 16 to 24, not better, it's one of the good part. And 18 to 16, average one. And 0 to 8 means it's a more difficult one. So accurate routing, hierarchical routing, subnet support, efficient forwarding, we are using the longest prefix match concept. I think we already covered this longest prefix match in internet protocol, internet INW subject in the IT, for the IT. Okay. And now we are moving to most closely to our syllabus part, that is Linux kernel implementation of routing table. Again, according to Linux routing implementation, match exact host route, match network route, use default key. Already explained this concept following in the Linux routing decision process. The routing subsystem bothers only about the next hop for the given destination. It is select the best possible route for the given destination in case there are many choices. Okay, and one of the important mechanism following by the Linux routing system is policy-based routing. Okay, and current implementation on Linux takes into account the following criteria to build a policy to route a packet that has originated from the system locally or that has originated elsewhere. List the entities. These are the main entities to build a policy to route a packet. Okay. So what is policy-based routing means? The router daemon itself maintaining a policy. So whatever the decision to be taken, that will be according to the policy. Okay. So policy means is a general concept. We are and this is the packet coming from this particular point, and that particular if that particular point matches or the policy or one of the policy in a better line means we are using that policy for that particular packet. That is a concept. Okay. So here the main entities related to build a policy are one is destination net ID. Okay. This is derived from the source IP and by applying an appropriate net mask to it. And then source net ID, okay, derived from the destination IP and by applying an appropriate net mask to it. And type of service, okay, the IP header has a type of service field that is used by the, okay, that is already in the IP header. I think type of service, you have some idea on type of service. And forward mask, in the case where multiple routing tables are configured on the system. So there are several routing tables are there. So which routing table we have to choose. Okay. So in a particular point itself, routing daemon itself, we have multiple routing tables. So which routing table we have to choose. Okay, that is the case. For that we are maintaining the policy, and the forward mask will decide. The packets are marked by the routing subsystem to use a specific route. We take this also into consideration while setting policy for the route. Okay. So configure IP route forward mark will set the policy. Okay, I will give some idea in between the description. Okay, and incoming interface. This is the interface from which the packet is arrived. So we can make a policy based on the interface, incoming interface also. So this is the packet coming from a particular interface that should be forwarded to this direction. That is the case. That is the rule. So when we are preparing the policy, all the criteria we are the entities provided here will be the matter. Okay, and class ID config which class that particular destination address is included. According to that, the route will be policy will be prepared, and according to the policy, the forwarding will be takes place, or the routing and forwarding will be takes place. And for configuring policy-based routing, we use the IP rule command. The rule option consists of a selection criteria based on which we use the routing table from the multiple routing table. So adding the IP rule, the packet with the source address, IP address 1 should use the routing table. This is the mechanism of the rule. So IP routing and IP rule creation is there. So IP rule creating, or in order to configure the policy, we are using the IP rule concept, IP rule command. So using the IP rule, we can maintain the policy. Okay, we are maintaining that the packet with the source address, IP address 1 should use the following type. So for the IP rule command, there is a syntax. There are some functions related to IP rule command. And using that functions, we are implementing the IP rule command. Okay, so in that function, we have a specific variables are there, and that variables, using that variables, we are providing such a rule. So the packet with the source address, IP address 1, so that is one part of the rule, should use the routing table 1. Okay, so routing table 1 means there is a device or the interface will be provided. So all the packets with the source address should follow the interface, routing interface ETH0, and all the packets with the source address, IP address 2 should use the routing table. So IP address 1 and IP address 2 are general terms, so we can provide the exact addresses. Okay, so it's actually it is a load balancing approach. In order to balance the load in a particular routing table, we are making a policy, we are making a rule. So according to that rule, the load balance will be takes place. Okay, so this is the concept, or this is the mechanism following in the IP rule concept, and we are providing the conditions. Okay, we are providing the conditions. According to the condition, the routing will takes place. That is the policy based routing. Okay, so this is the example or a diagram for the traffic on R1 is routed through routers R2 and R3 based on policy. Router is configured with the policy routing for packets coming from network N1, that is R1, with type of service bit set to T1. Okay, here source net N1, type of service T1, use link L1. Okay, there are 3 rules. Okay, 3 entity of the rules, and is a high speed link. All other packets are routed through link L2, which is low speed network. Okay, this is the policy mechanism. So we can maintain that particular policy. So R1 check the policy, check the rule, and according to the rule, whatever the packet reached at the point of R1, it will forward corresponding packet to either link L1 or either L2. So sometimes so many links are there. So for every link we can prioritize, or we can make the conditions on different entities. Okay. Okay, policy routing act as a load balancing that I already told, and IP route and default via IP address 1. Default is also already given, and IP route added. Okay, here the first rule says that IP route, particular specific route, add default via IP address 1, and the interface is ETH0 to table 1, and IP route add default via IP address to device ETH1 table 2. Okay, so we are comprising them, all the addresses, grouping the addresses into different tables. Then add the policy rule to the routing table based on the source address. That is also possible. From IP address 1, tab 1, priority 500. IP rule, it is passed to tab 2, priority 6. We are maintaining different rule. We are adding some rules, and it will be the policy, and according to that policy the routing will takes place. Any queries you can add to the message box. Okay, I think are we following the session? Is it okay? Because some initial introduction needed, that's why I'm going through this part. That is so sometimes you have some idea on this area. So any problem with the session you can give in the inbox. Okay, because it's an online session, so I couldn't get your feedback in direct way. So any problem with my session you can give in the message screen. Okay. I think yesterday it is a practical session, so it is more interesting one. Here initially we have to go through the theory concept. Okay. So can I continue?
Yes, sir.
Okay. So this is the multi-pathing concept. Another concept is multi-pathing. Multi-pathing mainly maintained with the earlier three steps we are following with the forwarding. Okay, either exact match or the default way, etc. And there we are giving multiple rules, new rules based on the policy. So that rule again providing the multi-paths. Okay, more than one path to particular packets. Okay, sometimes packet from same address or with some conditions will be passed to different path. So it consists in multi-pathing. So config IP route multi-path is a kernel option to configure multi-path. Fib select multi-path function is called from IP route output slow or IP route input slow to select a default gateway from multiple gateways when the kernel is compiled with the config IP route multipath option. As shown, multipathing parameters are embedded in FIB NH object entries for each gateway. These are part of the FIB. So in the following session we will pass the FIB part. Okay, and this is the function, corresponding function for the multipath in Linux routing table implementation. Okay, that we'll discuss later also. About FIB means forward information base. Forwarding information base, that is FIB. It's a table, so there's a FIB table is there, and there we can maintain the multipath. Okay, and FIB power, there's a value. Based on the value we are assigning power to each entry is assigned. Assign means power means it deciding number of hash tables we are using in our routing table. Okay, that is also explained in later concept. Okay. So gateway does multipathing. So here we have the network and packet reached a particular point. Okay, service provider 1, service provider 2, service provider 3, and messages reaching from the network at this point, and according from this gateway different path will be selected. ISP1 same data from the same network, sometimes same host, but it will be passed to different tables. Okay, and here gateway acting as router for incoming traffic with configured multipathing R2 distribute incoming connection request to different servers S1, S2 and S3. R2 is acting as load balancer. So this is the point for the multipath. Okay, multipath point is R2, and R2 based on the policy at R1, R2 will balancing the load to different servers S1, S2 and S3. Okay, and this is the basic program. I think I copied from the textbooks, so whether it is have the clarity or not, that I don't know. Okay, this is the algorithm for the fib select multipath. So according to the fib power value, fib power means we have a table, and the number of tables in a particular router will be decided by the fib power value. Okay, fib power value. So in order to select the table, we have the hash value, hash tables, and number of hash tables according to the fib power value. If the power value is 2 means there will be 2 square hash function. So it is easy to, or as fast as we can access a particular table. Using the hash, we are accessing the table. In order to choose the hash value, hash functions, the value of the fib power will be chosen. Fib power is 3 means there will be 8 hash functions. So we can approach, we can access the table as fast as possible. Okay, and change next hop in power equal to 0, change next hop, and next hop greater than next hop flags, and RTNH dead power plus equal to NH and NH to weight. So the value of hash value is higher means we will choose the particular weight, and according to the weight, the hash function value we are assigning to the next hop. Okay, there are different table. The table will be selected using the hash tables, hash function. So the power value, based on the power value, there are different hash tables, and the hash weight will chosen the hash function, and that function will direct the corresponding table. That is what going with the fib select multipath. I think there are multiple tables are there in a particular router itself, maintaining multiple tables. The tables are chosen by hash function, and what is the number of hash functions, or what number of sets of hash functions, that is decided by fib power. Fib power is 1 means only 2 hash functions. Fib power is 2 means there are 4 hash functions. Fib power 3 means there are 8 hash functions. So 8 hash functions means there are 8 ways to select the table. Okay, 8 ways to select the table. That is what multipathing. Okay, so in a single routing point itself, we have multiple tables, and multiple tables are chosen by multiple hash values, and that is decided by the value of the fib power. So that is the sequence. Now we are moving to the Linux kernel implementation of routing table and caches. Okay, so the routing cache is the fastest caching method for finding the route. So what is the need of routing cache? That is the first point we have to look, and the information base we are following in the Linux kernel is FIB, that is forwarding information base, FIB. The FIB also offers a method to find the route, but the lookup time is greater, and for each single packet to run a fib query impact the performance, whereas the routing cache reduces the lookup time for finding the route information. So that is the importance of a routing cache. In between the router and the FIB, Forwarding table. So we have a forwarding table. Instead of a single forwarding router, we have forwarding information base. From that information base, we have to identify a particular forwarding ID. Okay, that is the case. So number of forwarding tables are there, and we have to identify our forwarding ID. We have to linearly search. Okay. So in order to avoid such a linear search, we are using the hash concept. So according to the hash, the fib tables will be grouped. So there are 8 hash table, means there are 8 set of forwarding tables. So if it is our table is in the first set, or our table is in the next set, or the last set, we can decide it through this hash value. Okay, that hash value will decide the forwarding table for a particular ID, destination address. So every time directly searching the fib table is a time consuming part. Okay, that is the next information. So we have several tables. So some hash value is there. So we just moving using the hash value, we are identifying a table, and we have to search on that table whether that ID is there or not. And if the ID is there, we will forward. So it is a time consuming part. And we are frequently searching the same thing. Sometimes the incoming packets from a same source, so it should be passed to same destination ID. It is possible. Okay, it is there in a network. It is there. We have several data from one point to another, one common point to another common point. So there comes individually we have to choose that particular table from the table information. So it is difficult. So in order to avoid such difficulties, such a overhead, we are using the cache concept. Okay, fib offers a method to find the route, but the lookup time is greater, and for each single packet to run a fib query impact the performance of the system, whereas the routing cache reduces the lookup time for finding the route information. Okay, that is what we are moving with the cache. A single routing cache is shared in the case where multiple routing tables are configured for policy routing. The routing cache keeps every route that is the used recently in a hash table. It also maintains timers and counters to remove the route that is no longer in use. Okay, that is the usage. So once we used a table, that fib table will be part of the routing cache. Okay, so the next time one destination ID looking for that particular table for forwarding is it initially just search in the or just look upon the routing cache, and that particular address route is inside the cache. It will identify the route and it will forward the packet to that particular route. So there is no need to fib table lookup. Forwarding information based table lookup. Instead of that, we are looking on the cache. Okay, and then it comes the another question. There will be a query, that is, we are following the cache, and so many forwarding information stored in the cache, but cache is also a limited one. Okay, limited. It's a small memory. Okay, so we cannot maintain all the values in the cache. Okay, so there comes frequently refreshing the cache. So there are some functions are there, timer functions are there. Using that timer function, we will refresh the cache, and in between we will remove the unused route information from the cache. Okay. Unused means there are some reference count will be there. For every route, we have to maintain a reference count in the cache, and the reference count means once, and there's a timestamp also there, and it shows the frequency of the usage of that particular route, and there is an expiry part, and that expiry will decide expiry reached, a route reached at a expiry point, that will removed by the cache, removed from the cache through some timers or periodic timer or flush timer. We can remove such expired routes from the cache. So that is what the maintenance of a cache. And routing cache and FIB. So the basic main points, main data structures in the Linux routing implementation, they are root cache and FIB. So the working part, root cache and FIB. So then application, and there is a socket connection, TCP version 4 connect. So it is connected through TCP. Then there is a function IP route connect. So it has to forward to a particular route. Okay, forward to a particular route, and it will check in the routing cache RT hash table. There's a hash table. So using the hash table, we are locating the routing cache. Okay. If the cache, so if it is there, okay, cache is okay. Okay. It identifies the route and it will forward it. Okay. No problem at all. And if the cache is missing the cache means we have to look up on the forward information base. Okay. We have to look upon the forward information base. That is what given here. So routing cache is there. We can retrieve the route and forward the same. If the routing cache is miss, means that particular route is not in the cache. So we have to look upon forward information base, which contain local tables, main tables, and FIBs, forwarding tables. So according to that, the data will be forwarded. Okay. And new route IP is coming to the system. Again, using netlink socket, we are adding, update the kernel routing table. We are updating the routing table inside the FIB, forward information base, inside the. So routing table will be updated with new routes, and for the existing route, look upon routing cache first, and particular route is not showing inside the routing cache, it will be forwarded to routing table or FIB. Clear? So what is FIB? FIB, Linux kernel internally stores routes in FIB tables. FIB contains destination, gateway, interface, and route metrics. The main information on FIB, destination will be there, gateway will be there, interface will be there, and route metrics, hops, etc. These are contained in FIB tables. Okay, that how we are maintaining, that is in the following slides. And in order to implement the routing cache, okay, this is the concept we are following. This is the concept we are following. Okay, so there is a hash table function. Hash table function. This contain. This is the main hash table, and we have the information. This is the routing cache information. Okay. So number of hash functions are there, buckets are there. So we are grouping the total table into different buckets. Okay. So that I already told. There is a value known as fib power. So fib power is 3, means 2 raised to 3. There are 8 routing table hash buckets will be there. Okay. And that hash buckets providing two variables, chain and lock. Lock means it's a read-write lock. Okay, because there are parallel hashes are there. So we have to choose one critical entity. So there we are using the lock mechanism. And the another variable given in the RT hash bucket is chain. Chain means it represents all the roots inside that particular hash, or the roots identified by RT hash bucket 1. That is the content of the RT hash bucket chain. So every RT hash bucket has chain. So corresponding addresses to that particular hash bucket will be connected through the chains. It is a link, self-referential nodes. Okay. Structure concept. So self-referential structure that is connected. Okay. And what is the content of a routing table? And routing table, each hash bucket will provide the routing table information, and it contains RT flags, RT type, RT destination, RT source, RT interfaces, gateway, key. And what is the content of the key? What is the content of the key? The key contain again destination, source, and interface. Okay. So these three values, or these values of the key matching with the content of the R table means that table will be selected. So that table will be selected as R table. Okay. So this contains several addresses, and using these three key values, we are searching on the R table, and key is matching with an entity means we will extract that particular routing table information. That is the information the packet looking for. Okay, that packet looking for. So this is the overview of routing cache implementation. Okay, major routing cache data structures. So there are already it is given in the diagrams. So RT hash bucket stores hash chain of root entries. Okay. It's a structure contains the chain element and the read-write spin lock. Okay, there's a spin lock. And the chain element includes the list of R table structures that represent the cache entities. A particular hash bucket contain several root table root entries, and that is represented through the chain. Okay. So actually it is a linked list. So using the linked list, we will locate a particular root under a particular hash bucket. So that is the case. That is the working. Okay. And R table represent the routing table of cache entry. One of the entry identified as R table. And DST entry, generic destination cache structure. In general, what is the destination cache concept? And that is given in DST entry. That is also we have to explain. There are something to be explained there. DST entry, that is, the structure contains protocol independent destination cache definitions and pointers to the destination specific input and output function and data. That is DST entry. Sometimes we have to look up on the information base itself. That is decided by DST entry. Neighbor stores ARP or neighbor information for the usage of ARP concepts. The neighbor structure will added. and HH cache, that is the hardware header cache. So these are the major routing cache data structures we are following in the routing cache. And the purpose of routing cache. Why routing cache is needed? That is already told to easy access, fast, efficient access. Every packet requires a full FIB lookup. Otherwise, longest prefix match becomes expensive because there is no hash bucket. If we are not maintaining routing cache means there is no hash bucket also. So we have to directly linearly search the FIB. And if packet forwarding latency increases normally because we have to search the forwarding ID and identified it, and then only we can forward it. So it will take time. And with routing cache, previously computer routes are reused, faster packet forwarding and reduced CPU overhead. And structure hash bucket represents one bucket in the routing cache hash table. Hold linked list of routing cache entries. Okay. This is the mechanism. Structure RT hash bucket, struct R table, star chain, and spin lock T lock. Okay. So it's a spin lock and there is a table chain. So chain of the table. It is a self-referential structure. Table, it is a sequence of linked list of routing information. Okay. And complete hash value, select bucket, traverse, linked list, match, destination, source or type of service. So what is we looking for? That will be provided by the route lookup. And next is structure R table. It is a purpose represents a routing cache entry. This is the most important routing cache structure. And there is a header file, net routage. So when we are doing simulations or some demonstrations, we cannot make the program for these concepts because all are in the header file root.h. So we have to maintain the program only, but and use the functions, corresponding functions and structures that they are included in root.h, net bar root.h header file. Okay, so DST entry and then the R table next, then flags, type, etc., gateway, key, and peer. That is neighbor concept. Okay, and route flags. There is a entity in route table, that is flags. What are the flags? Local destination, RTCP local, then broadcast, then multicast, then invalid route, then directly reachable. So these are the flags when we are following. We have to broadcast means it's a broadcast. Local, so the destination inside the local means local concept. We have to forward it to a group. It's a multicast concept. Dead means expired things, and directly reachable cases will be part as RTSCF on link. So these are the flags. And there are types: unicast, local, broadcast, and multicast. So type of packets or type of packet forwarding will be decided through route types. And DST entry structure is a generic destination cache object looking used for routing, packet forwarding, neighbor management, and included in the DST.h net bar DST.h header file. Main entry next, reference count is there, and net device is there. Long last use is there, long expires is there, and neighbor part is there. Okay, so next means pointer to the next DST entry instance from the list for same root cache hash tables bucket. Okay, we are looking for a set of routes, so that will be provided through the next variable. And the reference count to keep track for entries to in use or deleted. The frequency of referencing that will be provided by reference count. So the reference count value is greater than 0 means we cannot remove that particular entry. If reference count becomes 0 means no one referring that particular entry. So we can remove that entry from the cache. That is the meaning. Okay. And device, that is providing interfaces will be provided. Then long last use. So we are taking one entry from the cache and using this unsigned long last use, we are identifying what is the last time that particular entry used. Okay. Unsigned long expires. Again, at the time of refreshing the cache or a periodic refreshing, we have to remove some data which are expired. So that is what we are looking through this expires value. Okay. And neighbor, that is already told in when using ARP or a data link concept, that neighbor concept will be used, that structure will be used. So these are the structure concept of destination entry. Okay, what we are looking for, that entry will be provided like this. Okay, if it is shown as expired and still there means we can refresh it. So at the refreshing time it will be removed, and we are looking freshly. We have to look in the fib, forward information base, and we have to regain that fib. From that route will be regained from the fib and will be added to the cache as in fresh. Okay, so that is the DST entry part. Neighbor, okay, again it is in the ARP concept, and Ethernet headers repeatedly avoid rebuilding. Okay, they are using the hash concept. So these are the major basic structures we are using for the routing cache data structures. Okay, so next part is managing routing cache. So I'm taking a 5-minute breaks. Okay, after that 5 minutes I will join. Okay. Okay, start ചെയ്യല്ലോ അല്ലേ? Okay, next is managing routing cache. Okay, so initially the implementation part, what are the data structure related to routing table and routing cache. That is what already explained. Now we have to manage the routing cache. Management is one of the most important functions of the Linux networking subsystem. It stores recently used routing information. So we know the things uh, in between forward information base, or we directly look upon the FIB. We are maintaining a hash. There's a cache memory, and inside the cache memory we have the recently used routing informations. So in order to maintain the routing information, we have the hash table is there, routing table is there, and the DST entries are there. These are the concept. Okay, and using this concept, how to manage the cache. That is what in this particular section. Why routing cache management is required? As packets flow continuously through the system, thousands of route entries may be created. Many routes become unused, some routes become invalid, interfaces may go down, gateways may become unreachable. Without the cache management, memory usage increases, stale routes remain, incorrect forwarding may occur. These are the problems when related to routing. Okay, this is the problem with every network concept. Okay, and continuously packet flow will be there, and thousands of route entries. If you just check your system is connected with the route, and one of the tool to show the data means it will continuously flow. The packets will be flow into or flow in the display. Okay, so many routes become unused. Sometimes almost one or two routes are always busy, but many routes not busy. Some routes become invalid. Already expired routes may be there. So interfaces may go down. We added some interfaces, so those interfaces are not working, and gateways may become unreachable. Some of the problem, any of the attack or any other things, some of the gateways are not reachable, and these are the problem we are expecting. Without the cache management, memory usage increases. Again, we are not using cache, or we are not managing the cache means sometimes we cannot enter into the cache. A new route will come, and that route cannot be added to the cache. We have to directly look upon the FIB tables. All are problems. Okay. So we have to lighten those problems. We have to reduce those problems. There comes the managing. And what is the management part? Remove unused entries. So there are several entries. The reference count is 0. Reference count is 0 means no one referring that particular entry. So we can remove that entry. And remove expired route. Some entries already expired. So we have to remove such routes. Handle link failure. Already told, unreachable. Any problem in linked state concept, there may be some in between routers failed, so link may failed. So the forwarded data not reaching the point. We are just forwarding the things and the data continuously using, because not reached means again the problem error will be reported, and repeatedly we are correcting. There are corrective measures So data continuously sending, that's there. Free unused memory. There are unused memory is there. So how to locate it? And remove expired routes, remove, there comes the unused memory. So how to deal with it? Improve lookup performance, prevent stale forwarding information. Okay, so all those improved, or the efficiency of the system will be improved by cache management. Any management things are like this. Okay, we are managing managing a point means to improve the efficiency part. Okay, and the main functions are IP route output key, route lookup, IP route input, incoming routing, SK DST check, validate socket route, check expiration, may expire, expiration decision, DST free, release route, DST destroy, final cleanup, and cache flush, flushing the cache. Okay, these are the functions to manage the route, managing the route. Okay, I am only giving the function terms, and the some explanations will be there that will be added. Okay. So the first one is IP route output key. Okay. First one is IP route output key. So this IP route output key, that is the important function related to managing the cache. Okay. This routine traverses the chain of routing entries to find out if they have hit the cache. Okay. Traverses the chain of routing entries to find out if they have hit the cache. So, one of the purpose, whether hit the cache hitted. That means entry is inside the cache. Okay. So that is the first point. So the main data structures are R table. Okay. Structure R table. Routing table will be there and the key will be there. Key is the destination. What we are searching, that is the key, and route table. So route table in the cache. So searching the key in the route table, that is what done by IP route output key. Route cache lookup, destination route lookup, route validation, route cache entry creation, forwarding decision for outgoing packets. So these are the things done by IP route. In textbook it is given, the code given, these are the functions, the code given, and textbook itself defining which line specifying each concept. Okay. One is looking for the cache entry, and second one, we check the entry for matching route key. So whether it is matching or not. Again, we are looking, initially checking the route entry, and it is whether it is matching, the key matching or not. And if we miss the cache, FIB is consulted to build a routing entry. The cache is not showing the entry. That means we have to add that entry. So we have to add means initially we have to add it to FIB, forward information base. Initially add it to forward information base and then add it into cache. That is the order. Okay. If we miss the cache, FIB is consulted to build a routing entry for the requested route by calling IP route output to slow. Okay. So the related function. This is for routing cache or checking the cache only. If the route is not showing inside the cache, we will call another function, that is IP route output slow. Okay, IP route output slow. So that will invoke FIB. Okay. We are invoking FIB means we are adding the entry to the FIB and adding it into the cache. That is the result by this particular function. Okay, and so main entries are there, and next is this is the function usage. Function is elaborated in the textbook. Okay, exactly what are the we are checking. Checking means we have to check a destination. We have to check the source part. We have to check the interface, incoming interface and outgoing interface. All should be checked, and if they are matching means entry inside the cache. If it is not matching me, we will invoke IP route output to slow function and add an entry to FIB, forward information base. Okay, so that is the usage of, that is the part with IP route output key. And next is routing cache for local connections. Local connection. Linux kernel maintains routing cache entries for local TCP UDP connections to avoid repeated route lookups for every packet. Once a connection is established, the routing information is cached and attached to the socket, significantly improving packet forwarding performance. So routing cache for local connections in Linux kernel. That is the second case. So locally, a particular node have some connections, or server have local connections using TCP and UDP, and that is cached in this particular cache to avoid the repeated inquiry. Sorry, okay, repeated route lookups. Okay, so that also one part of the managing routing, managing the route. Okay, managing the routing cache. Okay, and there comes some functions such as TCP V4 version 4 connected TCP connection setup, then IP route output key, route lookup, that is already we told, key using key, and SKDST check, validated cached route. Okay, we have an entry, and that entry is validating with the entry in the cache. Okay, we have to match the source address, we have to match the destination address, we have to match the input interface, we have to match the output interface. That is the validation part. And then packet transmission, that is IPQ XBit, maintaining a queue. Okay, and attach it to socket. That is the part. Okay, that particular entry. So this is what done through routing cache for local connection. These are the main functions. So TCP version 4 connect will establish the connection, TCP connection. Then normal case, that is if route output key will look up on the route, particular route, and DST check will check the validity or check the valid cache entry, check whether it is a valid cache entry or not. And the fourth one is IPQ XNIT or transmission. That is just we have to attach the entry to the socket. Okay, we have to create the socket, and the socket will be using that particular address. Okay, so that is what done through the routing cache for local connections. Okay, so that is the second function in managing cache. Now third one is link. I'm just making an overview. If you have more information needed, you can make the query. Okay, these are the codes are in the textbook, so I cannot follow within this period, small session. So I'm not going the complete information. I'm just giving the overview of each function, important functions. Okay. Now the third task for managing is link failure and reporting to routing subsystem. Link failure and reporting to routing subsystem. The Linux kernel continuously monitors the status of neighboring host, gateways, interfaces, and routes. When a link failure occurs, such as ARP resolution failure, interface shutdown, or gateway unreachability, that is ICMP part. The networking subsystem detect the problem, invalidate affected route, update routing cache entries, and report the failure to the routing subsystem. So these are the job here, link failure and reporting. Actually ICMP functionality. Okay, we are reporting internet control message protocol. Using that we are reporting to IP. So the pre points we have to done before sending the ICMP packet. That is what link failure and reporting. Okay. And here we have the functions or main files are, again we have some files are given here, core neighbor.c, and all are in the net.h header file. So that is what we have to include, and IP for root.c, IP version for ICMP.c, net bar core dst.c. So all are inside the net.h file, and the important files or functions in this particular section are a timer handler. Okay, timer handler is the routine that is run when the neighbor timer expires. Okay, so that is the part, detect neighbor timeout. So that means the some error situation. Okay, that is the link failure part. A message, a packet came, and we check the DST and the DST in the cache, and we just forwarded. That is the normal procedure. But the error packets are more in a particular period. So they are thinking, what is the problem? And there comes the link failure mechanism, link failure managing. So because of some other reason, packet is not reaching at the destination point. Okay, that's why the error. So there comes the link failure management. Okay, then night timer handler will detect neighbor timeout. That is the function of that particular function. Okay, and it probing whether there's a entry value that it probes, and whether any problem. Okay, and if the problem is there, that will be attached there, and that according to the result we have to refresh on the cache. And DST link failure, report root failure. Okay, one of the failure, destination not reachable. I think ICMP message, one of the ICMP packet. So before generating the ICMP packet, we have to get this error, report root failure, and that is managed by DST link failure. And then IP version 4 link failure. So IP version 4, the routine send out an ICMP error message to the originator. Okay. So corresponding to report root failure, DST link failure, we have to send the ICMP case. That is IP version 4 link failure. Okay. And DST link failure. Then IP version 4 link failure. So corresponding to DST link failure, ICMP has to send. Then next is DST set expires. Calculate the expiry value relative to the current value. And there are some variables in particular function. Okay, that I already initially I explained some functions. That root function is there, main function is there. So in that function, we have, that is root output key. Okay. So there we are checking the expiry value concept. Okay, okay, and that will get the expiry variables. Okay, then cache flush invalid routes. We have to remove the invalid routes. That is the flushing part. And DST destroy. We have to, sometimes some link is not working, so we have to destroy or remove the same from the cache. Remove the same from the cache. So these are the part of link failure and reporting. Okay. Now the next part is managing part is routing cache for the incoming packets. Routing cache for the incoming packets. When packets arrive at a Linux system, the kernel must determine how to process them, whether to deliver them locally, forward them, or discard them. That is the managing of incoming packet. Okay, Linux uses a routing cache for incoming packets. Purpose of routing cache is packet for localhost. Should packet be forwarded? Which interface should be used? What is the next hop? Which route matches destination? Without cache, every packet requires full FIB traversal. Routing becomes expensive. So these are the purpose. Okay. So without the cache, every packet requires full FIB traversal. It makes routing expensive. So to avoid that, routing cache for incoming packets in Linux kernel, and the main routing subsystem is consulted for every incoming packet in the same way it is done for outgoing packet. So that this is a part of incoming. Okay, incoming packet. Earlier we told about the outgoing case. Here the incoming part. We need to know if the incoming packet needs to be delivered locally, needs to be forwarded, is a multicast or a broadcast packet, and so on. So several identifications are there. Okay, incoming packet needs to be local or needs to be forwarded, is a multicast or a broadcast, and so on. All this information available from the routing entry corresponding to the packet, and a further course of action is decided based on the information. So there comes the function IP route input, incoming route lookup. Okay, and IP receive is there. IP receive finish to get the routing information for the packets. IP receive, that is the receiving part. IP receive. Okay, IP receive, and in order to find the hash, that is compute hash, RP cache code, fib lookup for fib traversal, DST input to packet delivery. Earlier the same case, but here we are managing with the incoming packets. Okay, we are managing the incoming packets. There comes the IP route inputs. Okay, and there IP route, first the hash bucket is identified for the packet, and then the collision list for the bucket is traversed. Okay, that is the first point. That is in the IP route input function. IP route input function, the first thing we are following is we are finding the hash table, corresponding hash table. Yeah, first the hash bucket is identified for the packet according to the destination entry, and then the collision list for the bucket is traversed. We have to match the key. We have to match the key. Okay. The last, we have the matching routing entry for the packet. The last use field of the entry object is updated. Last use will be updated because currently it is using. So last use will be updated. In the DST entry, this value indicate when the entry was last used. So that value will given the last usage of the packet, and we can see the details. Okay, we can see the details earlier already given. And then next we increment the reference count for the routing entry for calling DST hold. There is a function DST hold. Using the DST hold, the reference count will be incremented. That means what all number of extractions for that particular entry. Okay, if it is 0 for some time means we can remove such entries, but reference count will be incremented. Okay, we do this to avoid destruction of the routing entry before the packet is either sent out of the system or delivered locally. Because if the entry expired and reference count is not updated means sometimes by the refreshing it will be removed. So to avoid such a removal, we are incrementing the reference count. Okay, incrementing the reference count, and this is in the cache. If the cache is not showing that particular entry, we have to look up on the FIB, that is fib lookup. Okay, fib traverse. We have to traverse the fib and find out the entry and find out the key matching with the entry means we can deliver the packet. Okay, if it is for incoming or local connection, it can deliver the packet by matching this concept. Here we are not forwarding the case. If it is matching, we can use. If fib traversal also shows the negative means, you have to add that entry in the fib for the later usage. Once in the fib, it will be added to the cache also. So for the next incoming packet, it is the procedure will be end at the cache point. If it is we are not added means again for the next packet entry also you have to repeat the same procedures. Okay, next is routing cache timer. Already, what is the usage of cache timer? That is already told. There are two system-wide timers relating to routing cache management. They are periodic timer and flush timer. Okay, RT periodic timer and RT flush timer. So here clean expired routes, reclaim memory, remove unused cache entries, maintain routing efficiency. Okay, with the timer. We are not using it, again it will affect the efficiency. Routing cache grows indefinitely. Stale routes remain. Invalid gateway entries persist. Memory. So for the old case, we added one route with some other gateway, but currently the same route comes with a different gateway means the earlier one is an invalid entry. Okay, invalid gateway entry. So such entries should be cleared because sometimes we are using in from some other network or some other system. It may change. So according to that, that interface also changes. There updation needed. Otherwise, it is a expired. It become an expired old cache. For that, we have flush timer and periodic timers are used. Okay. Flush timer and periodic timers are used. And periodic timer that is kicked off at the boot up time when a routing subsystem is initialized. Once started, this timer will never stop but may not necessarily happen at fixed frequency. Okay. Once implemented, it will periodically refresh. Okay, periodically refresh. And periodic route cleanup. And flush timer means we are flushing. In between, we are trying to refresh the cache. There comes the RT flush timer. Okay. So the key components: RT periodic timer, RT check expire, RT may expire, RT flush timer, and DST free. So we are clearing the DSTs, entry, that DST matched destination entry, making it free. Okay, so that is what about the managing root cache. Okay, that is all about the managing root cache. Now the next concept is implementation overview of FIB. Implementation overview of FIB, forwarding information base. So that is the main database for a particular point, a routing point. Okay, we are keeping all the route base data information in that FIB. Okay, whether it is inside the cache or not, first of all we will add that entry to the FIB. The forwarding information base is the core routing database used by the Linux kernel to determine packet forwarding path. Whenever a routing cache miss occurs, the kernel performs a FIB lookup to identify the best route using longest prefix match. Okay, so we will choose the best route forward, or the entry contain either local delivery or network concept or forwarding gateway concept. So whichever is the most matching, okay, that will be added as the entry. Okay, that is what we have to look upon. And this is the FIB part. Okay, forward, it is a large diagram. FIB information. Okay, forward FIB implementation. This is the concept. So we have 256 tables are there, 0 to 255. So that is the first part we have to remember. In the Linux concept, we have 256 tables are, FIB tables are there. Not one table, we have 256 tables. So for 0 to 256, we have to corresponding searching mechanism also needed. And in order to help, or in order to improve the search fastness, searching efficiency, we are dividing this 255 under 32 zones, 0 to 32 zones. Actually, it is the net mask. Zone means it is the net mask, 0 to 32. So mask is 32 means it's the direct entry. Okay, the mask is 32 means the direct entry. So 0 to mask is 0 means there is no connecting entry for the address. Okay. Only for the forwarding purpose we can use. Okay. So if there is a gateway or a forwarding router, that 0 masked packet will be forwarded to that particular router. Otherwise we cannot follow. And up to 24 or 16 we can consider the network, corresponding network. Extract the network, and according to we can take the decisions. So here we have the FIB table. FIB table, 256 tables are there. So it contain a structure for the FIB table. It's a structure part, and it contain any number. If we FIB table 1, FIB table 255, etc. Okay, and the main content are TBID, table ID is there. That means 0 to 255. The numbers from 0 to 255. That is TBID. And TB stamp, TB lookup, TB insert, TB delete, TB dump, TB flush, TB get info, TB select, default, TB data. These are the contents. Okay. Some of them are functions. Can be stamp, timestamp, then lookup, table lookup, then table insert into that particular table, table delete from an entry deleting, dumping means we are keeping all the information in the table, and flushing to remove some entries, and get info to get the information on particular entry, and then select default entry for that particular table, and then data. Okay, these are the information inside the FIB table. And there is another case is FN hash. Okay, so FN hash contains zones and zone list. There's a zone list and a zone number. Okay, according to that, 0 to 32. 0 to 32. So 33 zones are there. So zone will be we can identify it using FN hash. Okay. Then we will get the FN zone. Okay. That's a link. Next zone, etc. Okay. Then FN zone contain next hash, device, hash mask, order and mask. These are the information related to that FN zone. Now, using the hash table, so here we have 0 to 15 hash table. Okay, 255 by we are dividing the zones. Okay, there comes we are deciding some hash concepts. So there are 16 hash concepts are there, and using the hash concept we can locate a particular node. So these entries are divided into zone, but they are for the search mechanism, they are divided under 16 hash tables. Okay, and each table looking for FIB node. Okay, FIB node contain next info, key, type of service, and then type, scope, state, etc. Okay, each node contains those informations, and our destination entry will check with this node. Okay, then finally the node information will be extracted. Node information will be extracted. That is the operation on FIB implementation. Okay, so just remember, for there are FIB tables are there, 56 tables are there, and those tables are undergone under 33 zones. That is for the matching, longest prefix matching, that to help longest prefix matching. And we have all the tables will be divided under a number of hash values. So if we are using a FIB power of 4, means 16 hash tables are there. Okay, so we will get there's a function hash. From that we will get the hash value, corresponding hash value, and using that hash value we will query the hash table, and it will identify a particular content of that particular table, hash value, and that table will be looked upon, and if they are matching, key is matching with the node, that will be extracted, that information will be extracted. That is the procedure in FIB implementation. Okay, so FIB table, routing table, FN hash organization, FN zone, prefix length zone, FIB node, individual route entry, FIB info, route information, FIB rule, policy, rolling rule. Okay, so then maintaining the policy. Okay, policy, that's the rule. Okay, that is the part of rule. And corresponding kernel files are all are in net.h, fib hash.c, fib rules, root.c, and IP fib.h. Okay, these are the PIP structures. Okay. Now how we are implementing? So what all we have to implement in Linux routing table? There we have to implement routing rules. Okay. Using the data structure, routing rules, routing tables, and routing cache. These are the three implementing data structure. Routing rules means for the policy based routing. We are maintaining the rules. How the particular routing table should proceed with a particular entry. Either it has to match with the local delivery, or local delivery itself. We can decide on we can prioritize them, and a routing table, whether routing table, maintaining those routing tables and maintaining the routing cache. Okay. Implementation by through forwarding lookup functions, management functions. Lookup function, FIP table lookup, cache lookup, etc. Management functions, already I explained how to manage failures, how to manage the cache, etc. All are under the implementation part. And next is adding new entry in routing table using IP command. Okay, it's an interface, routing table netlink interface. Linux provides routing table management through the IP command, which communicate with the kernel using the RT netlink interface. Instead of directly modifying kernel routing structures, user space utilities send netlink messages to the kernel, and the kernel update the forwarding information base and the routing cache accordingly. Okay. So in order to implement our case, we can use any of the tools, either Wireshark or TCP, dump, etc. And managing with our own routes, it is sometimes it may affect. So it is better to go with the network tools. Okay. And for updating the routing table and adding a new rule for new routing table, following two options of the IP command are used: IP root option and IP rule option. Okay, IP root option and IP rule option. The following functions are registered in net IP version 4 device net inet rnet link. Okay, it's a header table. So these routes are under header table. So we are only using the functions. Okay, inet rtm new root, inet rtm del root, inet dump. Okay, again to add the rules, again using inet rtm new root, inet rtm del root, inet dump rules. Okay, so these are the functions mainly following for the addition of new entry in routing table. So that is, we are not the entry is not showing inside the cache. There comes the addition of new entry to the routing table. Okay. Okay. What happens when the IP command is run with a root option for adding an entry in the routing table? It is used for route management, interface configuration, address assignment, neighbor management, and policy routing. Okay, so IP command with route option. We have route management is possible, interface configuration, address assignment, neighbor management, and policy routing. So the one of the main function in adding a new entry is inet rtm new route. It adds a new route to the FIB. Okay, the main contents are RT message, struct RT message. Okay, struct RT message. Okay. This structure is used for representing the user arguments set through the command line for adding a new routing entry in the routing table. So, what are the informations we have to use or we have to make an entry, those informations are under strict RT message. Okay, routing table message. Now, strict kernel RTA. This data structure represents FIB internal values. It is used for assigning the values to the FIB data structures whenever there is an update to the routing. And function hash insert. This function is called for adding, inserting route information in the FIB table. New zone, FN function new zone basically gets the strict FN hash pointer and the destination address bit length as parameters. FIB create info, the main parameters passed to this function are the RT message struct and the kernel struct. It starts with allocating the memory for the FIB info struct. Then hash insert. Hash insert, check if zone is already exist. Okay, no angle, we have to add the new zone. Already added means yes, key equal to F zone key computes the key using destination and net mask. That is the hash function, hash value. And using that value, FIB create info, create the new FIB info instance. And FN rehash zone. And we are adding the new entry, FP equal to FZ chain. Okay. Scans list to find the same destination or with the same destination and a type of service. If exist, insert, create or replace. Okay, remove old FIB info. If not existing, insert new FIB info into hash table. So according to the zone, that zone value and I think that explained here. That zone value and from the zone list zone value, using the zone value, finding the hash. Okay, so that hash is used to find out the location. Initially, corresponding table will be derived and the key will be searched. If the key matched with one of the entry in the table, it will either replace or remove the old one. If it is not matching entry, we will insert the entry into the table. That is the process. Okay. INET RTM new route, adding route, FIB table insert into FIB, FIB lookup, route lookup. Okay. And these are the kernel files corresponding to that particular FIB, adding to entry to the FIB. Now, the second part, that is adding rules, FIB rules. Okay. Here INET RTM new rule, the same functions, connect, same name, similar name, similar function. INET underscore RTM underscore new rule. This function add a new rule or policy to the new or existing routing table, FIB initialization. After that, the same procedure, FIB initialization procedure. Okay, this is for the new rule option. Okay, and when the IP command is run with a rule option for adding an entry in the routing table, important functions. Socket, we have to create a netlink socket, send message, RNet link receive request, then adding the new rule, rules lookup, and then the FIB lookup, rule traversal. Okay, so according to that route, we are identifying the rule. Okay, we are identifying the route entry in the table. Okay. Okay. Now FIB initialization, and this is the procedure. Forwarding information based initialization process prepares the Linux kernel routing subsystem for packet forwarding and route lookup operation. Okay. Linux initializes routing table, policy routing rules, lookup structures, and RT netlink interfaces so that the kernel can perform efficient route selection and forwarding. And here INET initialization, IP initialization, IP link initialization, IP fib initialization. All four functions are there. Then from the IP fib initialization, config IP multiple tables. Yes, fib IP rules initiate and IP fib initialization. If config multiple tables are not, means local table and main table, fib hash init and fib hash init. Finally, internet protocol fib initialization. Okay, this is the traversal part. IP root output, IP root output key. Already we mentioned these functions in the different stages. And this overall fib traversal, that is initially IP root output, then IP root output key. Okay. Then root is in routing cache. So whether or not root in the routing cache. Yes, return root information. So no fib traversal. Okay, we will get the IP root output. No, that means the searching entry is not in the cache. Searching entry is not in the cache. So there comes fib traversal. Okay. So IP root output is slow. So corresponding to fib traversal, if the entry is not in the cache, the corresponding function is IP root output is slow, because the fib lookup is a slow process. And fib lookup. Okay. Then hash, corresponding hash lookup. And for zone, finding the zone from the list, and using the zone number, we are finding the key. Okay. And from that key, we will locate the hash key. We will locate the fib tables. Okay. The chain of entries are there. If key equals function key, yes, error, fib semantic match, f equal to function next, fz is equal to zone next. Okay, there itself we can go for the next node. There itself we can go for the next zone. Okay, then hash lookup, function lookup, because we have the initial cache value, we will get a case, we will get a zone. So it is matched, then only we can proceed with that particular corresponding tables. If it is not matching, we have to find the exact cache. Okay. Then hash lookup, function lookup, hash equal to RT hash code, error, RT intern hash. And IP root output is slow. That means it is not in the cache. So IP root output is slow. IP root output key, IP root output. So by looking upon the fib, we will get the exact entry. That is the slow part. Okay. Up to that point, we are looking on the cache. Okay. But in no zone, no node, we are identifying the matching entry. Then it will check the fib entry. Up to that point, it will check the cache entry. So these are the mechanism for the rules, fib rules. Okay, fib rule mechanism, it contains next, client reference, preferences, table, action, etc. So whatever the rule we have to follow, we can add such rules. Okay, and fib rule next. Okay, client reference, preference. Okay. Table. Okay, this is the concept. This continually we are adding new rules. So according to the rule, we are identifying the entry from the table. Okay. Here routing tables, fib tables. There are 256 tables. So fib table. fifth table, etc. Number of tables are there, and if they are matching, this is the fifth table. 254 is matching. So ID 254 is stamp, lookup, insert, delete, dump, flush, okay, etc. And from that we corresponding zone and the hash value will be generated, and using the hash value corresponding zone will be checked. Okay, and if the entry in the cache or in the table we have the corresponding zone, and from that zone you will get the corresponding node. This is not for the cache, this is only for the FIB routing tables. There are 256 routing tables are inside the FIB. So we are locating a particular node inside this table. So there comes the hash value. Using the zone number, we have a corresponding hash value that will identify the corresponding zone. And from the corresponding zone, the values will be extracted for a particular node. This is the procedure for FIB checking, routing table lookup. Again, zone node and info. Okay, FIB node from the zone node info. Okay, the same thing. Routing cache. Again, hash bucket. From the hash bucket, R table will be there. From the R table, we will get the entry, corresponding entry. Sometimes there is a neighbor concept, sometimes there is a peer concept. According to that, that will be connected. Okay. These are the corresponding functions. IP route input for the incoming packet, handling incoming packet. Input slow, incoming packet handling using FIB lookup. Okay. Then locally generated packets, creating RT key structure. That is for the forwarding function. Okay. IP route output, then IP route output key, searching entry. Okay. If not found in the cache, using the key, we are searching the routing cache. If it is not finding, then we will call IP route output slow, IO slow for FIB lookup. Okay. Searching routing table, local vs non-local, local IP, local delivery, non-local, DST output, entering the result into routing cache. Okay. Once we look upon the fifth table and finding it out, we will be add one entry, one copy to the cache, local cache. Routing table contain permanent entries, routing cache contain temporary entries. Maintained by admin, dynamically created. User used for lookup, used for faster access. Okay. So these are the concept related to cache and routing table. Okay. So here we can go for some hands-on part. Some commands are there. We are using some commands. So that commands can be done through the code. in order to view current routing table. Okay, so in order to view the current routing table, IP route show, IP route show. So we can identify the, I think for the experimentation, if we are adding routing table, etc., there comes, I think we have to use any tool. So I am just showing some related commands. So to show the view, to view the current routing table, okay, the command we are using is IP route show. Okay, so here comes the information. Each entry in a routing table shown as a route contains information such as destination, okay, destination, then gateway will be there, net mask, then interface, okay, so destination default, okay, then gateway provided 172.26.96.1. Okay, then interface it provided. Okay, Ethernet ETH0, then flags, proto flags, then metric, proto kernel. Okay, okay. Then here the gateway mask is also there. Okay. This is the default value, then the net mask is also provided. Okay. So initially we are showing only the current route information, IP route information. Okay. IP route to show, and the same command will be extracted through route -n also in a different way. Okay. Kernel IP routing table, destination, gateway, mask, etc. Okay. Showing the current IP Linux routing table. Okay. So it shows destination, gateway, mask, then flag values, then metric, then the reference, and use and interface, using interface. Okay. Okay. Then columns in route -n output are destination, gateway, mask, flags, metric a value used to indicate the cost of a route. Then reference, number of references to this route. I think almost the value will be 0 here. Okay, we are not referring anything, just showing the current Linux table only. Okay, use count of lookups for the route interface. Which interface we are following here? ETH0. Or we can create, if we are using any tool, we can create multiple tables, new tables, custom tables can be created. Okay, that I will tell. That is the case. Now, so route lookup already IP route to show, that is or IP route itself give the route lookup. Okay, IP route. Okay, IP route it shows like this, default via a particular value, that is a default value, then device interface ETH0, proto DHCP, okay, proto kernel, which is the kernel protocol, shows which kernel protocol, then source, okay, this is the source, Then metric. I think here the metric is not given. So, all values will be 0. Okay, we are not exactly providing what is the hope or the next hope. We are not providing like this. We are just showing the current routing table information. And default represents a default route. Okay, then I via the gateway address, then device, the network interface, protocol indicate how the route was added to the table, and scope link indicates that this route is for a directly connected to network. Okay, here 172.26.96.0/20. So 20 is the net mask. So it is for the corresponding network. Then source, okay, etc. That will be given. Now, flag values U for the uproot is active and valid. G for gateway, H for host, R for rejection, D for dynamic, M for modified. I think the earlier stage that is a in root hyphen N, sorry, root hyphen N, we have the flags. Okay, UG means uproot and gateway. U means uproot, active and valid uproot. And okay, so two information, ETH0 interface given. So corresponding flags also informed through root. Okay. Then network interfaces and routing. Adding static route. Again, objective is insert a route into FIB. Okay. So in order to add, we can add new route. Okay. So we are providing a command. Okay. So we added a root, sudo IP root add. Okay, root space add, and we have to provide the root and the gateway, etc. to the network. Okay, we are adding a route to the current table, route to the current table, and we can show RU to root hyphen N. Okay, so it is added, a new route is added. Okay, 10.10.10.0. So we can add new route with route to the current table. This is the command. Sudo means it's admin purpose. So IP route add, then what address should be added. Okay, interface mask should be the corresponding mask, and via what is the gateway in that particular table, and for the corresponding routing table, and using that gateway we are providing the interface also. We are adding a case, and there we can add more addresses, more addresses with our table. Whatever that we are getting, some incoming packet we are creating and sending from other side and receiving the case, according to we can add, or we can maintain a custom table also. We can generate as a common table for the system also. So here only the live concept only we are showing, just adding one route to the routing current kernel routing table. Now, 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 IP route get. I am giving one address. Okay, IP route get. So how to reach that particular address? That is the question. So here it's providing 172 via this, and source is given as 172.26.110.174 UID. Okay, so to reach the particular case, we are sending the data through this link. So in order to get to reach the particular address from our table, how we can send, that is the information given through IP route get providing the route. IP route get providing the route. Now, and in order to delete the route, you can use IP route DEL. IP route DEL. So any of the added route you have to remove, means you can remove using sudo IP route del. Note here, sudo IP route del. So that is the case. You can remove one route from the table, current table. So there IP route del, then which route you have to remove, specify the route, or you have to replace a particular one, or default, you have to change the default. Then command is IP route replace default via the, you have to give the route and the interface. Okay, sudo IP route replace default. So we are trying to remove the default path. There we have to use the command IP route replace, then write the default, then via new default value, and give the interface also, either through ETH0 or either through ETH1, etc. Okay. Now, again you can add routing tables. As a whole, you can add more routing tables. You can use, you can add those routing tables to a particular document. That is possible. And if you are adding a new table, and you can use that particular, or you can define that particular custom table. You are creating a new table and those informations, and to reach that particular table you can provide the corresponding route. So that is we are using add route concept again. Add route concept, and the command like this. That is command is like this: sudo IP route add default via. So this is one particular, we are defining a new route via this table, custom table. Okay, so we are adding route value to that particular table. We are naming a table, custom table, and we are adding routes to that particular custom table. So here we are adding sudo IP route add default via. So we are adding the default case to a table known as custom table. So providing a default gateway to custom table. So that is the command sudo IP route add default via address, then table, custom table. So here custom table is not created. Okay, so after creating the custom table, you can add more content, more addresses, more route to that particular table. That is possible. Okay, so currently here no custom table. We are not created a table named custom table. And similarly we can add rules. Okay, sudo again we can add the rule also. Sudo IP rule add. So we are adding rules. IP earlier we added root. Now we can add IP rule add from 192 162 table, custom table. Okay, so from a particular table we are adding some rules. Here again we are not mentioned any rule. Okay, the rule is from 192.168.1.10. So any packet reached or any location identified as from or source address. Here given source address. So from source address is given. So any of the entry which is matched with from 192.168.1.10, then it will be extracted using this rule. So we are adding a new rule. This is the mechanism for rule, maintaining rules. So we have to make any type of rules like this from this any of the root entry connected to this from source ID, it will be extracted using this rule. Similarly, we are adding some other rules, flags value, or using any interface connecting to a particular interface. All are we can identify using or adding new rule to the table, current table. So any type of rule can be added. One of the example is add from 192. So here we are giving the source address. So any of the packet reached, or already we added an entry as from 192.168.1.10. Then it will those routes will be extracted using this rule. So this is the mechanism for adding rule. So in our currently our table is a limited one. That is why we cannot give more example for the rules. If it is a large 200 entry or 100 entry, and we have to extract 5 entries with some condition, or 150 entries with some destination, etc. If we have to identify, means this rule mechanism, adding rule is important. Okay, so that is the next command. Now, show all routing rules. You can use IP rule list. If whatever the rule we added, all the rule list can be showed using IP rule list. Okay. IP rule list. And you can monitor route. Okay, we can monitor a particular route. IP monitor route, that is the command, IP monitor route, and provide the exact route, which route we have to monitor. So using sudo IP route, add that particular route. Sudo IP route add, we are adding some route, and before that IP monitor route, you are giving a command IP monitor route, you can monitor the route in real case. Okay. And some other tools also there, some demo tools. So currently I'm not going with that. And simple programs also there. Okay. So here are the information we are provided with the Linux routing table and the cache implementation. Okay. റെഫറൻസ് ടെക്സ്റ്റ് ബുക്ക് ഷെയർ ചെയ്യാം. നമ്മുടെ സബ്ജക്റ്റ് ബുക്ക് തന്നെയാണ്, അത് തന്നെയാണ് റെഫർ ചെയ്തിരിക്കുന്നത്. അത് ഷെയർ ചെയ്യാം. അത് ഓൺലൈനിലും അധികം കിട്ടാനില്ല, അത് ഷെയർ ചെയ്യാം. ഓക്കെ, ഇത് ഈ പ്രസന്റേഷന് വേണ്ടിയിട്ട് ഞാൻ ബേസ് ചെയ്ത ടെക്സ്റ്റ് ബുക്ക് ഷെയർ ചെയ്യാം, മെറ്റീരിയൽസ് ഷെയർ ചെയ്യാം. ഓക്കെ. ഡെമോയിൽ ഞാൻ പറഞ്ഞിരുന്നു അതിന് കുറച്ച് പ്രാക്ടിക്കൽ ആയിട്ടുള്ള ഡിഫിക്കൽട്ടീസ് ഉണ്ട്. അപ്പം അതുകൊണ്ടാണ് അത് ഇങ്ങനെ കാണിച്ചത്. ഇതാണ് ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള കമാൻഡ്സ്. ഇതാണ് ടു ആഡ് റൂട്ട്, അതുപോലെ തന്നെ ഷോ റൂട്ട്, അതുപോലെ തന്നെ ഡിലീറ്റ് റൂട്ട്, മാനേജ് റൂട്ട്, റീപ്ലേസ് വി ക്യാൻ റീപ്ലേസ് സംതിങ് ആൻഡ് വി ക്യാൻ ആഡ് റൂൾ. അപ്പം അത്രയും കമാൻഡുകളാണ് ഞാൻ മെൻഷൻ ചെയ്തത്. അപ്പം അത് കൃത്യമായിട്ട് നമുക്ക് കുട്ടികൾക്ക് ഡെമോ ചെയ്യണമെങ്കിൽ യു ഹാവ് ടു initially prepare a routing table list that you have to add or collect, download any routing table information, and using a document, and that document will be used for this purpose. Then you can extract, you can add a rule to that, you can add a new route to that particular custom table. So according to that you can maintain the whole application. Okay. So create a custom table and add a number of routes to that particular case, or you can download a list of routes, and those routes should be added to that particular table, and from that table, in that table you can apply these functionalities. If we are applying in live, sometimes it may make a problem. So that is why you have to create a convenient table, and whatever the information you are adding to that table is in your convenience. So you can add or delete, or you can add a new rule to this. In live case, if we are adding some rules or something, sometimes it may affect our system. So here or using Wireshark or TCP dump, you can get the data and dump those data. You can dump using a command and dump all those data, and finally use those data to extract the information or add information. That is better. Okay, so this is one part of the session. So I almost covered Linux kernel implementation of routing table and the caches. So I don't know how it felt to you. Is a theoretical part, so I covered the theory part. Almost demonstration part is covered. So you have to identify the functionalities and structures inside each function. You have to identify and you have to explain those things because this is a theory part. So for examination also it will ask. So I think the method I followed is better for teaching students also. Okay, that is my suggestion. You can use your own techniques. Any queries in this part? I think one more session I have to take today itself, but it is not possible now. So any suggestion or any query for the next session, you can ask. Any clarification? I think one more content that is this is also a part of today's session, that is data link provider interface. So I not completed that one. Okay. Any query? If there's no query, you can stop here. Hello.
Okay, sir. I extend our heartfelt thanks to our esteemed resource person, Dr. Dilip PK, for delivering such an insightful and engaging session and for sharing valuable knowledge with us. Thank you, sir. I also thank all the participants for their active presence and enthusiastic participation, which made today's session meaningful and successful. With this, we conclude today's session. The FTB sessions will continue tomorrow as per schedule. We look forward to your active participation. Thank you all and have a wonderful day. Kindly do the feedback form, please.